Thank you so much. Thanks for being here. This is my first State of the Lake. I read last year's very, very thoroughly because I knew that I was taking the job. And now here I am presenting the State of the Lake this year. And I really, really appreciate you being here. I really want to start off by thanking the folks who sponsor this report. As you heard from Kara, it's a huge group effort. And as you can imagine, in the summertime, our folks are fully tasked. And so this is a lot of work on top of everything else that they're doing. And they really do it with gusto because the State of the Lake represents an opportunity for us to actually synthesize the work that we're doing throughout the year and to put it in the context of the longer term trends that we see from the long-term research that we've been doing here, as well as thinking about how it relates to scientific progress worldwide. And so many folks who have supported the report specifically, we really appreciate those generous donations. I also want to thank all the people who contributed to this report. You're going to see some, but not all of them in all these photos. And so I just want to acknowledge that working with these people is absolutely my favorite part of the job. And I'm saying that as somebody who thinks that Lake Tahoe is really beautiful and the science is really cool, but these people are awesome. And it's been terrific to work with them and to work with the folks who fund our research, education, and outreach. And I want to give a special thanks to my predecessors. So as the new director, I'm especially grateful to Charles Goldman, who's here tonight, Jeff Schladow, and our interim director after Jeff retired, Alex Forrest. They've been just incredibly generous with their time, supporting me as I get my feet under me in this new job. All right, so I started on March 1st. And as Kara said, I'm quickly running out of time to say that I'm the new director. But I moved up here this winter after decades of working on lakes all over the West, working in Washington and Idaho, working in Nevada and California, and working on some of the big blue lakes in the world, like Lake Baikal in Siberia for about 18 years. But it's really, truly a dream to spend my days learning about this magnificent lake and to be in this warm community. So this is a quote that I really like from Sandra Postel. It captures, I think, some of the frustration that freshwater ecologists and other limnologists frequently feel. She says, for many of us, water simply flows from the faucet, and we think little about it beyond this point of contact. We've lost a sense of respect for the wild river, for the complex workings of a wetland, for the intricate web of life that the water supports. But I will say, not here, not at Tahoe. We know that freshwater is a place. And here at Tahoe, it's an epic place that just drops your jaw every time you turn the corner here. That you know that it supports the fish and the wildlife. The forest, streams, and the meadows are all inextricably linked with the water in this system. And with all the life that relies on these natural ecosystems. This water is famously clear and just wildly blue. That's my professional opinion. And it's a place that really invites all of us to have deeply personal experiences, immersing ourselves in nature. Its summertime beauty is renowned throughout the world, and particularly when it grows hot down in the Central Valley, right? The lake hosts millions of visitors every year. Yes, I know many of you have never seen this because you studiously avoid the beaches during those specific holidays. But yes, we host millions of visitors here. And of course, as you know, the Tahoe Basin is a winter wonderland as well, taking in unparalleled views on really great snow conditions. I mean, I have skied on the East Coast, y'all. So this is great. And of course, this brings millions of visitors to us every year as well. And these visitors sustain the economy in the basin and also in the region more broadly to the tune of 10 billion with a B dollars per year. And as a community, we are working together to figure out how we sustainably welcome 4 million unique visitors a year into a community of about 70,000 residents. So here in the basin, we're about a third the size of Yosemite, and we host 3 times the visitation as Yosemite. And Tahoe has long attracted visitors and residents who are interested in both developing the land for tourism and commerce in a spectacular location, as well as those who are really focused on environmental protection. So this is one of the quotes from Al Gore after his visit here with Bill Clinton. Lake Tahoe demonstrates that the environment is the economy and the economy is the environment. So UC Davis researchers stepped into this setting in the 1950s, beginning with Charles Goldman's Tahoe Research Group, aiming to provide the science that managers, policymakers, and concerned citizens could use to provide science-driven stewardship of the environment. And the accomplishments in both scientific advances as well as usefulness for conservation are really, they are too numerous to mention. I mean, this could be a week-long symposium. But they included a truly innovative study. And I wrote this before I knew Charles was going to be here. So I really would say these things. This really innovative study in the 60s demonstrated that even a tiny amount of treated sewage effluent entering the lake would cause blooms of algae. And this experiment really is so well known in limnology as being an audacious and creative experiment that really proved a point. And this was instrumental in managers making the decision together to move sewage effluent out of the basin. So that was a really key accomplishment for this basin. Speaking as somebody who's worked on a lot of lakes that had a lot of trouble moving people off of septic and moving sewage out of the basin. So over time, as physical scientists like Jeff Schladow took more interest in working up here, we also saw a greater body of evidence that the biology was not the only strong driving force of lake conditions. So Jeff's team provided some really carefully crafted models and measurements and evidence that the lake mixes fully to the bottom about every 4 years, and that this is associated with very cold air temperatures and big prolonged storms. Now, this is important because that water at the bottom, when it comes up, it's been down there a while. When it comes up, it's quite clear, and so it's a boost to our water clarity. It also brings some nutrients that have been down at the bottom collecting there, and that can help to fuel the blooms of algae as well. So we've been studying the nearshore environment for decades using some of the same techniques that were developed in the 1970s and 1980s. But of course, we've been expanding on them substantially, as I'll discuss later. So altogether, these decades of research have resulted in an infrastructure that is both broad and deep. So when I talk about infrastructure, I'm not just talking about buildings or equipment, but I'm also talking about these data sets and the knowledge that's been accumulated, as well as the people who have been engaged, people who are working at the center now, people who have been working with us for a long, long time, some of whom are here in the room and are still engaged and still helping to make the science terrific here. And of course, our partners who are looking to us for science and taking that science and putting it into action. So this infrastructure, from databases to technologies and people, allows us to understand a whole variety of processes. So healthy waters, we know, are intertwined with healthy surrounding land and also the health of the organisms that live in that space. So we study the health of the forest and their organisms, as well as the streams. When we get into the water, we study the way that the water moves horizontally in the lake, also vertically in the lake, how it moves along the shoreline, so that we can understand how materials move in the lake and how they may affect some of the things that we're really curious about, and such as water clarity and the algae that are blooming near shore. Now, in the Tahoe region, one of the things we see when we look at these long-term data is that one of the most important trends is the increasing air temperature. So the minimum temperature in particular, we see a pretty strong trend in which the minimum temperature is going up, and the days that the temperature is below freezing in the winter is 29 days shorter than it was in 1911. And so there's also a trend in the maximum temperature, but that temperature in the winter means that if the air temperature is not freezing, it's not going to snow. And so we see a trend where more precipitation is falling as rain instead of snow. So in around 1910, we would see that about half of the precipitation was snow. And now something like 30 to 40% of the precipitation is snow. So that is going to change a lot, not just for all of our winter recreation, but it really changes the timing of the delivery of the water to the lake and the nature of what is coming into the lake as well. So with the air temperature warming, we also see the water temperature increasing as well. So the annual average rate of water warming is about 0.21 degrees Fahrenheit per decade. So that's looking at all of the water in the lake, but it's most pronounced at the surface. So at the surface, it's 0.39 degrees Fahrenheit per decade. And you see that that warming in the summer is where the greatest warming is occurring. So the July average of 2024 was the warmest that we've seen in a 26-year record, where we've got some technologies that have been in the water for 26 years and give us really fine scale data. Definitely had a warm July last year. So as a general phenomenon, so I'm sorry, I'm going to step you through Limnology 101, and I actually do find that the folks who come to these events, you all frequently know all this stuff, but just in case you brought some friends who haven't seen this yet, I will step through a little bit of limnology stuff because this is really important to understand with warming. So when the warming is most pronounced at the surface, as it is here, there are some really important implications for lake mixing. So the principle is that warm water floats on top of cooler water. And so if you live in a house that has a stairwell, sometimes in the summer you walk up the stairs and you realize your head has started to come into warmer air. And then you realize the second floor is a lot hotter than the first floor. You can sort of remember that as what happens in lakes as well, that you get the warmer water floating on top of the cooler water. And as the difference in their temperatures increases, so you get hotter and hotter water on top of cool water, there's more resistance to mixing. So it forms a barrier. So that means that the oxygen from the atmosphere can't as easily get down to those bottom waters. And the nutrients that kind of accumulate down here in the bottom, they have a harder time getting back up to the top where the algae might use them. So over the past 56 years, this stratification is almost 14% stronger, and it's longer by 29 days. So when you hear us say that the summer is getting longer here, that's what we mean. It's this time of stratification when that warm water is floating on top of cool water and it's resisting mixing. So there's a longer period when that's occurring. And so that's a longer period that the bottom is going without the oxygen replenishment. So in addition to studying that phenomenon, we're also thinking about what's happening at the streams when they enter the lake during this stratified season. So when the streams come in, so frequently this is a big period of snow melt, that water is really cold when it's coming in the streams into the lake. And so frequently, if it's colder than the lake, it's going to plunge down the side and go mostly towards the bottom. If that stream, at various other times of the year, if that stream is warmer than the lake, then the stream water can float on top of the lake. And so you can start to think about what a big difference that can make when the streams are bringing in sediments and nutrient and plant debris and sometimes pollutants out of the watershed. It makes a difference whether they float on top or plunge to the bottom. And they can have big implications for clarity. And so we've got some great new equipment out in the water to measure some of those dynamics near the streams. So when we reviewed 2024, we saw that the upper Truckee River continues to be the greatest source of nutrients and fine sediments. And that is not a surprise. The upper Truckee River is where a big river meets at the lake, and that used to be a massive marsh system, and that's normal when a river meets a lake like that. So that's long been recognized as a source of sediment and nutrients. I just found this photo from 1969, and you can sort of see the plumes of sediment coming off, and this was during the development of the Tahoe Keys. So why do we track these things? Why would we be tracking sediments and nutrients? So sediments reduce water clarity, especially the fine sediments here. And with them come the nutrients that fertilize the algae. And so algae, I use the word algae, can refer to the single-celled organisms that are floating in the water, and that's when it's phytoplankton. It can also refer to the algae that is growing on rocks. And when they're growing on rocks, they're called periphyton. So nutrients, when they come into the lake, can boost the growth of algae. And, you know, algae are not all bad. It's not a question of good or bad because everybody has to eat. Everybody has to eat, and algae is the base of the food web. But we do know that when algae grows, and especially when it grows a lot, it can affect water clarity. And of course, those nutrients can also boost the growth of the periphyton, which can create some nuisance conditions. So we've been tracking sediments and nutrients for decades. Okay, so the nutrients that fuel the growth of algae are lower than they were in the 1980s. And this is undoubtedly thanks to the many large efforts to restore and protect the lake as part of management for the maximum daily, total maximum daily loads. Sorry, I got an acronym in my head. I couldn't get through all the words there. So, you know, hundreds of projects, a fantastic amount of money that's gone into restoring and protecting the lake. And you do see that reduction in nutrients. However, we have to acknowledge that it looks like phosphorus may be rising again, and it's not clear why. So in this upcoming year, we aim to dive into the data deeper and see if we might already have the clues that are in the data that we already have, or the extent to which new research may be needed to understand this more. Certainly, top of mind at Tahoe is always water clarity. And what we see in the data that has been collected here since systematically since 1968 is that you saw steep declines in water clarity in those first couple of decades up into the late 90s. And then, you know, coming in as a newcomer here, I looked at this and looked at the several different ways these data have been analyzed, and I see it plateauing. You know, there's a lot of variability, but it seems like it's kind of hit a plateau. And so the question for me now is really why? Why is it not getting better? So you see that in the winter, the clarity may be improving, or it may have also plateaued. In the summer, it's not getting better, and it may be getting worse in the summer. What we saw this past year, we know that particles are generally strongly associated with the water clarity. So these fine particles that are in the water reduce the clarity. And so we have several technologies. We've included several different ways you can look at particles in our State of the Lake report if you want to check it out. But essentially, we have some great technologies for just counting the tiny, tiny particles in the water. And generally what we see is that they track very well with water clarity. When particles go up, the clarity goes down. We did see in this past year at least one date in the summer where the particles went down, but the clarity did not get better. And so it does kind of make us scratch our heads and think that there is a really potentially very interesting story here in terms of what may be affecting the clarity. All right, so a quick review of what affects water clarity. So inorganic particles, such as sediment, ash, and smoke, certainly during fires, you see changes in clarity, and also organic particles. So these are the living things. So algae, or we can call them phytoplankton too. Also plant debris that washes out of the watershed. We will sometimes see those in samples as well. So these affect water clarity. And there was some wonderful work done in 2006 and probably for several years before that, because it was really, really detailed work. And it looked very carefully at these particles and what they were. And it determined that about 58% of the particles that reduce water clarity were inorganic. So there were these fine sediments that are reducing water clarity. And about 25% of them were typically the algae or phytoplankton. So the question that I'm asking, as we're sort of all puzzling about why is the water clarity not improving at this point, the question for me is, are these numbers still accurate? What is the nature of these particles now? This was almost 20 years ago. And we have to recognize that a lot has changed. Some important things have changed. I mean, for one thing, we've had many restoration projects, management actions that are designed to reduce the amount of sediments that have come into the lake. So we should expect some changes from that. We've also had more influence of wildfire. Wildfires don't have to happen in the basin in order for the smoke and ash to still influence the lake. They can come in through the atmosphere even when the fire itself is located elsewhere. And as I've mentioned already, the water temperature has gone up. So in warmer conditions, that really kind of speeds up the biology, and it also favors different organisms that like warmer temperatures better. And so, you know, you can think about when, you know, in your garden, you can put fertilizer on your seeds or your little seedlings, and you can give them some light, but they don't really take off until it gets warmer. And the algae is the same way. The warming can really speed up the growth of algae as well. Okay, and so now I've sort of talked about like how desperately I want to get into what are these particles. And just to assure you that I'm not just being a nerd, it is actually important. I mean, I'm also being a nerd, but it's because different materials have different fates in the lake. So they may not hang around in the upper part of the water column, affecting water clarity for that long, or they may stay up there affecting water clarity. So for example, sediments coming in will eventually sink, and they may aggregate and get bigger and then sink and stop affecting clarity. Whereas algae, these are living organisms. Algae make more algae. And so our expectations would be different depending on what these particles are. All right, and let's talk about how we measure the clarity of the lake. So we frequently kind of laugh about how the Secchi disk seems like very primitive technology for a lake that has a lot of really high-tech equipment. But as you've probably heard before, the Secchi disk, the reason that we love the Secchi disk is because it's an old piece of equipment. Anybody can fabricate one. So all around the world, you take a Secchi disk reading on the other side of the world, you'll be able to compare it with one you take here. You can also look back in time because the technology hasn't changed. And if you've ever looked at a Secchi disk, you can see there's very few ways that technology would change, right? So we can laugh about that, but I also really want to assure you, it's useful. But also, I want to assure you that we have a lot of other equipment in the lake that is measuring the optical properties of the lake in a lot of different ways. And there's a lot that we're able to do with those data. So this is just one example that we're really, really proud of. So in a recent analysis of our long-term data, Shohei Watanabe analyzed the penetration of UV light into the lake over several decades of measurements. And so just so we're all on the same page here, as light enters, it travels, some of it can travel far, like UV, and some of it just can't travel that far. One of the take-home messages for those of you who haven't thought about how UV travels in water is that yes, you can get a sunburn when you're in water. So wear your sunscreen. So UV is damaging to cells in the water just as it is on land, and not just for people. So it can also damage algae. It can damage other organisms that avoid it. So UV is really a very, very important factor in a really clear lake like we have here. UV also can degrade materials in the lake. So they change the chemistry in the lake. Just like it tears apart the paint on your house and it degrades your patio umbrellas really, really rapidly in Tahoe. It's also breaking down materials in the lake as well. And so we want to know about UV because that has implications for the biology and the chemistry in the lake. So what Shohei found, he found many exciting things in this study, but in particular, one important one was that dry years have higher UV penetration to deeper depths. And wet years, the reason why that is the case is that the wet years wash in materials from the watershed. So you can think about all that plant debris, all those sediments, they wash into the lake in really high precipitation years, and that blocks the UV from penetrating so deep into the lake. And so that is a really important thing for us to understand so that we know how to interpret some of the biological and chemical data that we get out of our long-term studies. So as I mentioned, UC Davis has been monitoring conditions near shore for decades, both with some of the older methods, collecting data by hand, and also with newer technologies that provide consistent real-time conditions. And so all of you can access some of those data that we're collecting both near shore and offshore. And we know that you do because when they go offline, you call us. And you tell us that you use these data every day to decide, should you wear a wetsuit? How thick should your wetsuit be? Should you go out in a boat? Is it safe? right? So we do get these calls, so we know that you're using them. And if you're not using them, I really invite you to do so. So the QR code, don't be shy about pulling your phone out and grabbing it. It's also is really fun if you've got a big wind, like a huge storm going on in the basin. Sometimes I'll go and look at the temperature data, and you can actually see the way that the wind has pushed warm water off of the west shore and onto the east shore, because you'll start to see cold temperatures on the west shore. So it's, you know, it's also useful, but it's very, very cool. So we've got 10 nearshore stations with real-time data, as well as some forecast. And the nearshore is where many important lake processes occur. It's where people interact most directly with the lake, and where most of the pressure from invasive species comes. So near shore, we've been monitoring that algae that grows on rocks, the periphyton. We've also been monitoring these metaphyton, and these are unattached mats of algae that kind of float around. And some of that growth of the periphyton and the metaphyton sometimes turns into a nuisance here. So many of you have probably experienced seeing big mats of dying algae or sort of semi-alive algae on the beaches. So some of the questions that we have are the same questions that you have, which is nearshore growth of algae increasing? And the data that we have say that there's no significant change detected in the growth of algae over several decades. But we have to say it is really, really hard to monitor periphyton and metaphyton here. So what we see is that there's a huge variation around the lakeshore, and even in a single beach, in where the periphyton and the metaphyton are growing. And so scientists, when we monitor, we will typically go to the same place over and over again. It's really, really important. You know, you're measuring the same tree over and over again, or the same transect, and that just doesn't work with these periphyton and metaphyton, because the mats will grow, and then we'll get a lot of wave action, and the waves will wash them off of the rocks, and then they just don't come back, or maybe they do, but there would be some periphyton mat growing somewhere else on another rock on another beach. And so it's hard with our typical monitoring approaches to get a really holistic understanding of how periphyton is growing throughout the lakeshore, and especially with metaphyton that just kind of rolls around. So we didn't give up. You don't think that we gave up. So we're trying a more integrated approach. So we're doing sample collections in the water. We do diving, where we do the same kind of collections we've been doing for ages, because we want to keep that long-term record going. But we're also adding imagery that we take with drones and with helicopters. And so the helicopter can do the entire lakeshore in an hour, and we can take images, and we're able to use machine learning to estimate the extent of periphyton cover in the images. And then we compare that to what the divers see in the water. It's really important, because this is not a well-established method yet. We need to understand how this method works. And so we have people in the water who are making sure that we understand what those images are showing us. I actually think Scott is one who's done a lot of that ground truthing. So, so we do think in the past couple of years that we've made a lot of progress in being able to stitch together the images and get really potentially very good data out of this approach. But it involves multiple factors at this stage. We also have a grad student arriving this year who's going to try to add satellite remote sensing, so that he He's going to see if he can calculate the coverage of these algae from images that the satellites take. And so we'll be able to get a multi-scale view of the periphyton and try to dial in the best way to most efficiently and effectively monitor these blooms of nearshore algae that I know that we're all concerned about. So nearshore is also where we see the most pressure from invasive species. And we've got a new grad student who is already starting, Grace Rosberg-Franceau. And she is going to test out the use of environmental DNA to monitor for invasive species. And so organisms, all organisms shed DNA all the time. And this is the whole basis of, forensic crime dramas, right? So it's absolutely the same in nature, that DNA is just being shed all the time. And water is actually pretty good about picking up the DNA of all the organisms that live in it or have passed through it. And so there are certainly still some technical challenges with applying it at Tahoe, but that's what she is working on with us here, because that could potentially be a very effective way to monitor for species who are otherwise hard to detect. And much of our current research in the forest is aimed at looking at what some of the drought effects are on trees like sugar pine and improving methods for reestablishing of trees after fires. So we know that the health of water and forest are intertwined, which is one of the messages that our education team spreads by training the next generation and outreach to both residents and to visitors. So last year we had over 10,000 residents and visitors engaged in various ways. We've got new exhibits on aquatic invasive species that you see right behind the bar back there. This one trying to teach people about the ways that their non-motorized watercraft can spread invasive species and how they can avoid allowing that to happen. We're developing new curriculum for healthy forest in collaboration with school district. And we have through our partnerships, we have presence now on the north, south, west, and east shores through various partners. And these partnerships are especially important. They're always especially important, but we were really feeling them this year as instrumental to our success because we did, this photo shows you 3 of our 4 wonderful AmeriCorps members. And this year, halfway through their terms, the AmeriCorps program was canceled. And so thanks to generous donors who responded incredibly quickly and really gave us peace of mind, we were able to keep our AmeriCorps members half-time on the education. We did have to scale back our education for this upcoming summer, but we were able to keep them half-time on their education, and then we put them half-time onto other research grants. And I think they're having meaningful experiences, which is what they came to TERC to do. But during this time, when we've had to scale back our education and outreach, and we can expect that that AmeriCorps is likely not going to be a program next year, we have been having to think really hard about how we continue to get the word out. And one of the ways that we're able to be resilient is through our partnerships. So many thanks to all of our partners who help us to do that. And we have a new collaboration with UC Davis, Cal Aggie Athletics. So they created a new Tahoe-themed jersey for their student athletes, for our student athletes. And so they came up and they got out on the boat, and of course they, sat down, do some reading, and learned about lemnology here. And this is our UC Davis mascot, Gunrock, here sporting that jersey. And I would never show you such a cool jersey without giving you an opportunity to purchase your own. So feel free, and I think we have the QR code outside as well. So I know I have some, my husband has some, everybody's got some of these great jerseys. And this year we also started the Ski with a Scientist program. So Allison has been leading that, and every session that we did was full. So I had no idea how many people wanted to just hang out with scientists. This is great. So that has been a real success. So our research and education has, by design, moved well beyond the scholarship and the education of UC Davis faculty and students. Informing management and policy in the basin has been an extremely important goal for UC Davis research up here since its inception, as well as the conservation and restoration practices that are undertaken by our partners. And to protect this ecosystem as a whole, we also need to really pay attention to the forest and the water that's moving through it as well. These systems are all linked together, as well as the special organisms that live here, right? And those that show us how interconnected the organisms of land and water really are. And our gathering here tonight is focused on Lake Tahoe, but the lessons learned here go well beyond this magnificent place. So Tahoe's water flows toward Pyramid, but there are many, many other headwater lakes and streams in the mountains that are the source of water throughout the West. And they experience challenges that are very, very similar to Tahoe. Looking forward, we need to anticipate that the challenges will intensify as areas of North America become less hospitable to people and to industry through heat, through storms, through sea level rise, and wildfire. And there have been studies recently that have mapped out how US populations are likely to shift northward and into higher elevations. And I don't have to tell you all that we've already experienced the edge of this phenomenon, right? I mean, we really do see it. It's a real thing. You're not imagining it. It is a scientifically demonstrated fact that when the temperature stays above 100 degrees for more than a day in the Central Valley in the summer, visitor numbers increase. Or during COVID, we saw people flee crowded conditions to be up here. And as the world changes, it is likely just the beginning of the changes that we'll see here. So building resilience in our communities and in our infrastructure and our ecosystems is key to building the resilience for future change. And the partnerships are working towards the same goal as many of them have already in Tahoe in many ways already. And of course, we're continuing to invest in the science and the infrastructure that help us to understand and anticipate the change with partnerships and management and policy, conservation and restoration who can move this knowledge into action. So as a newcomer here, you know, these quotes all still resonate with me, and I don't know if they all still resonate with you, but I feel like Mark Twain is one of, I think, many who summed up that feeling of awe that you get the first time you crest the hill and you see the lake lay out before you. So this is from Roughing It. At last, the lake burst upon us. A noble sheet of blue water lifted 6,300 feet above the level of the sea and walled in by a rim of snow-clad mountain peaks that towered aloft, full 3,000 feet higher still. As it lay there with the shadows of the mountains brilliantly photographed upon its still surface, I thought it must surely be the fairest picture the whole earth affords. And, you know, sometimes it may seem like the work is too hard when especially when there's a lot of uncertainty and there are a lot of things changing fast. But I would bet that everyone in this room is here because the work is too important. And this place is way, way too important. And I feel extremely grateful to be welcomed into this strong and warm community where no one needs to be convinced that protecting a healthy lake is important. We know that it's important, and the real question is, how do we do it? Thank you. Oh, yeah. Ooh, questions. So just a few minutes, so we want to make sure that everybody gets a voice for any questions that we have. Right in front of Elise there, and then we'll right here. Yes.
Yeah, apparently we're not immune to the
Yep.
We need to summarize the questions so that our online audience can hear them.
Yeah, thank you. So the question is about microplastics and how significant is the problem of microplastics in Tahoe. So, so we certainly know microplastics now are really everywhere. And we do help our partners at Desert Research Institute to monitor microplastics. We have an atmospheric deposition bucket that they use. And we do a lot of education and outreach about microplastics. The question of how significant the problem is in Tahoe, I think, is still an open question. The methods for monitoring and researching microplastics are really rapidly evolving, but I know that we're all making efforts as a community to reduce the potential harm that microplastics can have by entering the lake.
Honestly, I think there's a lot of people around the lake that don't realize that. And later on, you were saying that, you know, the wet years, the sediment washes and the nutrient washes. Well.
Yep.
And that's also causing heart issues, but also hurting us with the algae situation. And you had said that the algae isn't bad, but it is bad when you get algae blooms, toxic blooms. And we have measured, and we have not toxic algae. We have measured the MPA. Paid for it, I don't know. And so it is a concern.
Yep.
And we've talked about we need to stop trying to get nutrients in the basin. We're keep fertilizing our yard. Talked about why is phosphorus increasing. I talked to a landscaper. He said these trees are coming in with phosphorus. You can see the white in the container.
Yep.
I have 3 construction projects in my street, and they're throwing in trees.
Yep.
A lot of trees, and they're just filled with phosphorus.
Yep.
But nobody's monitoring that. Nobody's saying, we need to get that taken off of the tree before you put it in this. And you need to get those stuff out of the basin. You can't be bringing the fertilizers in from Home Depot. And
so I think I could probably summarize your question for the folks who are online, because they may be wondering why it's just gone silent. So I think your question is, it's about controlling nutrients. So the issue is that we know that sediment and nutrients wash in from the basin, and phosphorus in particular is frequently associated with sediment. And a lot of it is natural, but certainly we have fertilizers that people use in their yard, definitely can bring in additional nutrients into the basin. And so, you know, so I don't know about the regulations that are occurring in the basin. I will say that everything that we can do to reduce the amount of sediment and nutrients coming into the lake is a good thing. As I said earlier, and you were sort of asking a little bit of a question about whether algae are good or bad, I will say that every lake has algae, and they have to have algae. You know, algae they turn the energy from the sun into food for everybody else in the lake. And so every lake is going to have a baseline of algae that is absolutely necessary. And so I cannot villainize the algae overall because they're doing their job. But certainly I understand when there are blooms of algae that is a concern. So I think that's, yeah.
Charles, this 30 years ago, we did not have the algae on the rocks that we have now at the near shore.
Yep.
It is a different animal right
now.
And I know it's heated, you know, it's warm.
Yeah.
But I'm sorry, we keep putting more nutrients in. We need to stop.
Yeah, I'm very, very interested in studying more of that. Yeah.
Not allow nutrients and fertilizers. 14 was, and the board said it would be too heavy-handed for us to ban fertilizers.
So that's not what we regulate. So we're going to have to cut this off, but that's a valid point, and we accept that. But we do the science and we provide the science.
Yeah.
I have a question. You brought it up as a joke. Have you looked at the type of sunscreen from the visitors how that affects this summer? Lack of clarity, because I know over 10 years ago it changed from the spray sunscreen that are just oils to the mineral sunscreens as a spray form. And I know from vacationing in other places that they ask you when you go in the water, did you put on mineral spray sunscreen? And if you did, they won't let you in the water. So something changed it. So that could contribute as well as a completely unknown. The other question I have is, do you have any more data on the microplankton like the Bosnia and the Daphnia? We heard last about it and Dr. Shiro was still here. And I really would like to see how that story evolved.
Yeah, great. Okay, so we've got two questions there. One is what we know about sunscreens and the different types of sunscreens that people have used. We know that in the ocean, in particular around coral reefs, sunscreens are very tightly regulated because they have been found to have adverse effects on the coral. I do not know of any sunscreen research that has happened in Tahoe or honestly in any other freshwater ecosystem, but I think it would be interesting to look at. I do think that, you know, we should remember that Tahoe is a really big lake and people are interacting right at the edges. And so I don't know how much of an effect the sunscreens would have on the lake as a whole, given what a large volume of water it is. But I think it's totally valid to look at. The second question was about what's happening with the zooplankton. So the zooplankton are the microscopic animals that eat the algae. And I know that over many decades, Charles Goldman's group began looking at the interactions between the Daphnia and Bosmina with the algae. Daphnia and Bosmina are really, really good at eating algae. They can eat a whole lot of it pretty fast. And they saw that a rapid decline in those two types of zooplankton was coincided with a change in the water clarity. And so there's forever been a question about the relationship of Daphnia and Bosmina with water clarity. So right now we have a lot of gaps in our zooplankton data. We've got a grad student back there whose face is completely lit up right now because he is working on trying to understand the zooplankton data. No, he had this huge smile when I looked back at him just now. So he is working on that. And we are also working on updating the data that we have on the mysids, which are those larger shrimp-like organisms that eat the zooplankton. So in the next year, we are planning to dive into those data in a more holistic way to look at them.
Time for one more question, right there.
Yeah.
Thank you. 30 years ago, we used sand on our road. Now we're using more and more salt. That salt has reached bedrock, and there have been increases in this recent testing in the last 5 years. And so the increase there, and according to this increase in salinity can lead to a phenomenon called internal phosphorus loading, where the phosphorus stored in the lake sediment is released into the water. Could that be part of this process?
This is a really interesting point. I'm going to repeat for folks online. So in the Tahoe Basin, there was a move from sand on the roads for winter conditions towards salt. This is true in many parts of the world. In particular, in North America, it's been studied really well. And that as salt moves into water, it can have really interesting chemical and biogeochemical kind of reactions that may increase the availability of phosphorus. And it's a totally valid area of inquiry. I don't know that it's been studied here. There's been a lot of study in the Midwest where there's so many lakes and so much winter and so much salt. And I think in the Midwest and in the Northeast, the salt is, there's so much salt entering the lakes that it actually changes. You get like a layer of dense salt water sitting on the bottom of lakes. And so they've got really tremendous problems with that salt water that I think it would be unlikely for us to get to that full extreme. But the thing you're talking about is a really interesting chemical, biogeochemical process that I would love to learn more about. And certainly as I think about these nearshore blooms of algae in particular, I am thinking a lot about the biogeochemistry. So yeah, thanks for bringing that up. Yeah.
There's one more question online.
Oh, okay.
So is Lake Clarity the most meaningful figure of merit for Lake Tahoe environmental quality? If not, what is?
Yes. Do I have to repeat this because it came online? Oh, okay. You got it. Okay. So yeah. So water clarity, is it the most meaningful indicator of, let's say, ecosystem health, I guess? So I would say that the Secchi depth is something that you can examine over time. So you can actually look at trends. And I think that that is one of the reasons that it's used as a central metric that we and everybody else working on lakes tends to use. It's also intuitive. Once you see it and you learn how it works, you get that idea like, oh, if I drop the quarter, I could also just see it disappear. You understand what that means to drop the Secchi disc into the water and watch it disappear. And so I think those are two of the reasons that we've used Secchi depth. Water clarity is, overall, we could measure water clarity a whole lot of different ways, and we do. Is it the most meaningful? It is very meaningful for sure. So it can tell you about, if it suddenly changes, maybe you have a big bloom of algae, or maybe you have a lot of sediment and debris that are coming in after a fire. So it is a metric that's really, really important to monitor, whether you use a Secchi disc or some other way of measuring it. But there are some lakes, not Lake Tahoe as far as I know, but there are some lakes in parts of the world where there's a lot of mining that are clear because they have a lot of heavy metals in them. And so in that case, you would need to know what's going on in that lake before you would rely on water clarity. So it can be specific to your situation, but certainly it's a very good indicator, especially if you've got a longer sort of experience of monitoring, then you can monitor change. And it's a relatively simple way to monitor a lot of the things that may have changed in your lake.
Good. We'll bring everything to an end.
Thank you. Thank you.